This is Astronomy Daily Live. Hey, everybody. Hope everybody's doing well. You can call me Cosmic, and welcome again to the Circle of Friends, gathering together slowly, ever growing, though, ever growing. So, hope everybody's doing well today. Everything's okay here. It was a nice, quiet, lazy weekend. Nothing too much going on. I want to get my smartphone started over here so I can monitor the live stream to make sure that all is moderately well. Looks so far so good. So hope everybody's doing extremely well today. I'm also going to pull up my chat, see who's making trouble in the chat. Uncle Bill is tap dancing in the chat tonight. That's nice. I know you have many talents, Uncle Bill. So tap dancing, I'm not surprised at all. And hey there, Tom. Nice to see you also. So cheers. Grab your favorite beverage or consumable of choice and come with us all on a fun, casual journey into the astronomical world. Cheers. One thing that I'm going to start trying to do better is looking right into the camera as opposed to looking at me. I don't know if that makes uh, don't know if that makes any kind of difference in terms of a connection, but let me know if you notice anything different about how I'm looking at this now and how I normally look at things. Because yeah, I think it's a very subtle angle. It's maybe 5 degrees or so, maybe even less than that. But yeah, I don't know if that makes a difference in terms of connection or not. I've got to sort of angle my head down a little bit so I don't see. If I do straight on, then it's like I'm getting all the reflection off the laptop. But if I angle down just a little tiny bit and then look at the camera, um, yeah. So that's a little different, maybe a little better. I don't know. I don't know. So yeah, I hope everybody's doing really well today. As I said, things were nice and lazy all day today. Just kind of hemming and hawing around, enjoying the change in the weather a little bit. The Hurricane Bud, blew through over the past couple of days. Dropped a little bit of rain. Some places a little more, some places a little bit less. We, I'm maybe here. Maybe I got about an inch or so, which is extremely welcome. Especially these kinds of rains, which are a little bit slow, and so they soak into the ground. Really nice. But yeah, it's definitely the humidity is up and the temperature is following it. So on a misery scale, I mean, if you want to call it misery out here, which I can't. Um, yeah, it's getting a little humid, but hey, I don't mind one bit, one bit. So this is just a gathering together of friends. We join in a circle, or you can call it like a virtual porch, a virtual lounge, and we have, as I said, our consumables or other drinks of choice. This is hydrogen hydroxide again, fresh batch, the most amazing molecule in the universe. So cheers. Yeah, Uncle Bill, I don't think I was late. I don't think I was late tonight, but last night I definitely was, maybe a couple of minutes late. And the day before, I think I was about a minute late. But today, I think I was pretty much right on time. Right on time. But and excuse the pun, but yeah, keep me on my toes for sure. I like to hit it. I like to be on time. So that makes it um challenging without a watch usually. But but even without a watch, I usually can make any kind of appointments or things pretty much right on time. I usually like to get to appointments, a couple of minutes before I'm supposed to be there. So if I can do that, I'm fine. What saves me on this live stream, right, is that I've got this smartphone over here, and this smartphone I have set an alarm that will go off at 1:45 UTC every single day, and so that gives me a 15-minute heads up so I can grab the laptop and set up the camera and turn it on and go to the YouTube channel and, get all that um, set up. Um, and yeah, and it's YouTube lag, and I'm okay with that. I don't mind. Um, I but I definitely start right on time. What I want to do, um, at least eventually, is I want to do what Gilles does on his shortwave um, show, and that is have a big have a big clock, right? Have a big huge clock so you can see what time it is here, and you can judge the lag um, from that. Usually, when I'm watching his live stream, I'm usually around 10 or 11 seconds um, behind, or yeah, well, it, whatever it is, there's a lag of about 10 or 11 seconds or so. So I sort of expect the same thing uh, with this. So yeah, Uncle Bill, I when I started my live stream a few months ago, I posted that fact on the weekly Space Hangout Slack channel, and what I wrote there is that I will post um, once in a while, but I promise that I won't be obnoxious or anything like that. I'm not gonna like post every day or you know all of that. And I think this was um, what I've been doing this since January, right? And I think I've posted the fact that posted something about ADL. I think maybe this was the third time, maybe the fourth time or so. Um, and I just, it's like, okay, I haven't done this in a while. I'm trying to find, you know, this core group that has the passion, right? That shares the passion, and and uh, and so I'm going to post over there because they said it was okay, and I don't think um, posting my link uh, um, 3 or 4 times in 6 months. I don't think that that's too obnoxious. But Nancy Graziano, she um, posted a thing right away saying, hey, is this actually 7 days a week? And It's like, yes, it is. Yes, it is. And so yeah, just not planned, not anything at all. She put that on the calendar. So yay, yay! I greatly appreciate the support. I PM'd her to that effect, and she's like, well, yeah, you know, sure you should. So yeah, I'm glad about that. As I said, I'm looking forward for my core for my core group, and I think worldwide, I think that core group is probably several hundred. Oh, I'm slanted now, and it's just a matter of time. It's just a matter of time, having a little bit of patience. Just I mean, this this live stream is for me very easy and very fun. It I mean it's yeah. It's sort of an obligation to a certain extent because it's like, okay, it's 2 hours UTC. I'm doing this, right? But it's not a huge obligation. Um, yeah, it's easy, and what I do, okay, and I learned this a while ago, right? Is that I'm not thinking about next week's live stream or next month's live stream or next year's live stream. I'm thinking about this live stream. That's it. I'm doing it one live stream at a time. And that's it. I'm not thinking about tomorrow's or next week or next month or next year or anything else. It's like, can I do this live stream today? And that's it. And that's it. And that's actually one of the teachings that actually comes out of that of that book, right? And it actually comes out of computer science. And it's not necessarily just a computer science thing, but that's where I first learned this concept um, of divide and conquer, right? In order to solve a big problem, or in terms of the Tao Te Ching, it's in order to do a big thing, do little things, and it's the same concept. You take this big thing and you chop it up into little pieces, right? So they're digestible, so they're manageable, right? And as you do all those little things, the big thing will emerge. It'll emerge naturally, right? It's probably the most famous, uh, or at least one of the most famous lines out of the Tao Te Ching comes from number 64, and there are I think hundreds or thousands of translations of this thing, but um, what it says here, right, is that a journey of 1,000 leagues starts from where your feet stand, right? So a lot of times that's translated to, you know, the journey of 1,000 miles begins with the first step, and it's one step at a time. So that's all I'm doing, and that makes it really easy because it's all I'm doing is this one. I'm not doing any others, right? That's it. So I was having a little bit of fun this afternoon, diving into the Gaia data release 2 again, and I actually posted a plot on my Discord channel, which Uncle Bill, since you have the permanent link that I still need to um, get, why don't you go ahead and post that on the chat, so we'll have an invite to my Discord server, and I think I put it over on the art channel. I think. Let me. I'm gonna go over there right now, and oh, not random.org. I want Discord. And let me. I'll go ahead and share my screen now, so you don't have to watch me with my mouth open, catching flies, going over to Discord. It's a little slow tonight. I was doing was and we're gonna do this. Hang tight, but I'll give you the ending first before we go through all the steps, because I want to do a special thing. Thank you, Uncle Bill, for that link. Appreciate it. Appreciate it. Let's go over here. Earlier today, I was watching Buckminster Fuller's um, uh, I think it's oh, I don't know how many hours, but it's just hours and hours and hours of this multi-day lecture um, called "Everything I Know," and so he did a brain dump, right? He did a brain dump, and these are available on YouTube. So I sort of encourage you to take a listen, because it's pretty amazing, pretty amazing. So there's Bucky. He's in this. He's getting up in age here, right? He's up in age. He was born in I believe like 1895, if I recall. So I think this was done in the 70s. So yeah, I mean, he was in his 70s, early 80s when he did this. Um, so yeah, I want to say this was done in 1973. So maybe he wasn't uh, quite 80 yet, but getting pretty close. Getting pretty close. So, but anyway, over on my art channel, I posted this plot, and we're gonna do this. We're gonna make one of these plots. But so what I'm showing here is I went to the GAIA Archive um, to data release 2, and I said, okay, grab me all the stars that are within, I think I did like a 10 arc minute radius, right? So I said, grab all the stars that are within 10 arc minutes of of the coordinates of um, the open cluster called M37. And the information that I want from that is not only the positions of where all these stars are, but what's called the proper motions, and that is the the measured motion of these stars in arc seconds per year, right? So that's what this is showing. Along this axis is showing the right ascension proper motion. And this goes, I know this is hard to see, right? But it goes from negative 10 arc seconds per year to positive 10 arc seconds per year in right ascension, right? Now, right ascension is essentially the same thing in the sky as longitude is in the ground. So, but this is measuring a velocity, right? Not a position. So, this is how many arc seconds per year these these stars move in right ascension, and then along this other axis here, right? This is along declination, and as you can see, so this is 0, 0 is right about here, right? So that's those stars. It's kind of hard to see here. So there's approximately 0 RA, and there's approximately 0 Beck, something like that. So at that position, these stars are barely moving at all, right, in the sky. And that's why we sort of have a cluster of these right around 0, 0, because, taking a sample of the sky, most of the stars in the sky really don't appear to be moving all that much at all. But what you notice in this plot is that a huge group of stars are all moving in about the same way that that isn't what all the rest of the stars are. Now, the other thing that I've done here is the size of each one of these dots signifies the brightness, right? The magnitude of these stars. So you can see that these stars, which are all sort of moving at um, 0 arc seconds per year, and there's a spread, right? There is a pretty broad spread, but overall, right, these are pretty faint. And these guys down here, as you can see, are overlapping, right? So we just have this big overlapping black blob. So, but what that means is that well, one, there's a lot of stars there, but two, most of these stars are brighter than these background stars. So I'm pretty sure that what we're seeing here, these are the actual cluster members. These are the stars that are members of M37, because as a cluster, as the story goes, right, they were probably all formed together at the same time and are therefore moving in sort of the same way, right? And so this is how um, the pros are able to sort of pick out um, which stars are which, right? So in this case, we're picking them out by how they move in the sky. And so as you can see, these guys are moving in um, sort of a positive right ascension. So they're all sort of moving towards the east, right? At about 2 arc seconds. See, that's about, see, here's 0, here's 5, here's 2.5, right? So here's about 2 arc seconds per year to the east. And then in declination, right, they're moving um, to the south at about maybe like 5.5 arc seconds per year. And there's a spread, right? There's a spread. They're all not moving exactly that much. So, you're talking two, 2 arc seconds plus or minus, I don't know, about an arc second or so, half an arc second um, per year each way. Yeah. So that's a pretty tight concentration. So, you know, the fact that these are, a lot of these at least are pretty bright, and there's a cluster of them like that, indicates to me, at least, that we're seeing many of the members of M37. So yeah, it sort of looks like a double cluster, right? A tight one and a loose one. But as I said, this is plotting motion in the sky, not position in the sky, right? The position in the sky would be um, would look different than this. So what I thought that I would do tonight, at least for a little while, is um, go over to the GAIA Archive, data release 2, and let's pull some stars and look look at their motions in the sky. And we're not going to be making any kinds of discoveries here or anything else, but it's kind of interesting to maybe see how these stars are moving in the sky. And what I'll be able to show you is, not only um, their proper motions, but also their positions as as well, so we can sort of see what that's all about. So I think what I want to do, um, so here's the Gaia archive, right? And what we're going to do is we're going to do a search. Now this is just a database, right? So it uses the normal kind of database query language. The nice thing about this is that for the most part they 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 will build the query for me. So that's very, very nice. I don't necessarily have to learn exactly what I have to ask in order to get the results that I want. The 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 uh, the difficulty though is I just want to sort of randomly look around, right? I just want to sort of randomly look around. So, you know, I either have to choose some kind of object name, right? Or I have to give it um, an RA and a right ascension and a declination. Um, so I'm thinking what I want to do is I want to let's randomly choose a right ascension and declination, and I'm going to sort of do this in a weird way, but let's see if this actually works. Okay, so right ascension um, is usually designated in hours, minutes, and seconds, right? But you can also designate it. Hey there, Atta. Nice to see you in the chat. Um, you come in whenever you want, anytime, anytime. So, but you can also designate right ascension in degrees, right? It's going to go from 0 to 360. But let's be a little bit more specific than that, and specify not only degrees but also arc minutes, right? So there are 60 arc minutes in 1 degree, and then there's 360 um, degrees. So in a complete circle, that means that there's 21,600 arc minutes. So let's have random.org choose a number between 21 or 1 and 21,600, and that will give us the right ascension to choose from, and then we'll do the same thing for declination, slightly different. So let's do this one first. Okay, so 9098. So 9, I've pulled out, of course, my handy dandy calculator here, 9098. And so that's the number of arc minutes. So we want to divide that by 21,600 and then multiply that by 24 in order to get. So why did that do that? 9098 divided by 21. Did I do something wrong here? 360 times 60? No, that's right. So 9098 divided by 21,600. So that's that times 360. Okay, so oh, that's why. Okay. Sorry, I'm doing things without letting you know what I'm actually doing here. Okay, so 9098 arc minutes. I'm just having to think. I'm having to think out loud. So we can just divide that by 360 to get the number of degrees. So I think we can actually give it number of degrees. So that's 25.2722. Okay, so declination goes from positive 90 degrees at the North Pole to negative 90 degrees at the South Pole. So that's a total of 180 degrees. So let's do 180 times 60. So there's, oh man, I'm going to have to, is that 10,800? I've got some bad news to actually report. Let me stop sharing here. I've got some really sad news to report. Just the other day, remember I was talking about the fact that I think I've had this calculator for like 20 some years or so. Well, just within the last 2 hours or so, I noticed that it was starting to do funny things with that fourth character. Do you see that? Watch, I'll put in all 9s. Look at that. Look at that fourth character. It's missing the top thing and the middle thing. So I can't read those numbers anymore. I don't know exactly what that is because it could be a 7 and it could be a 9, right? So when I do 180 times 60, 180 times 60, it's showing me that, which I'm pretty sure is 10,800, but it could be 18,800. I don't know. So, man, I think this calculator, which I've had for a very, very long time is not going to be functional anymore. Now, I want to say that I think something like this happened a few years ago to this calculator, and all of a sudden it just started working again. So I'm hoping that it comes back. But you're exactly right, Tom. I am not, at this moment, I do not have a calculator within arm's reach. So what I'm going to have to do is I am going to have to cheat. I'm going to have to cheat and pull up the calculator on the laptop, which, oy vey, I don't mind, but oh man, there it is. Ah, that's pretty fun. Let's see. Let's pull this up. So there we go. I thought that I had this under scientific too. Okay. So there it is. Yeah. Atta, you're exactly right. All right, so let's do this. 180 times 60 is 10,800. Okay, so let's um let's go from 1 to 10,800. 10,800. And we'll generate this again. 4401. 4401. I'm going to clear that. I'm going to go 4401 divided by 360. No, divided by 180, sorry. And then I have to, let's see, I think I have to 2445. How's that going to work out? 10,000. I didn't plan this beforehand. 4401 divided by 10,800. 0.4 times 180. There we go. Okay. So now I need to subtract 90 from this, right, in order to get the actual declination. So negative 16.65. I hope you followed that okay. How I arrived at that. Okay. So then let's choose sort of an appropriate radius. I don't know where this is going to be in the sky, so let's start with a radius that is the same radius as the size of the moon. Okay, so we're going to search in GAIA data release 2. And what I'm also going to do is we're also going to display some additional columns, right? And the columns that I want to show, all the ones that are checked here, are going to show up. But I want to also show the right ascension proper motion and the declination proper motion. Okay, so let's do that. And we can come back up here and let's show the query here just so you can sort of see what that looks like. Now this is in a language called SQL. I'm going to change the number of items selected to some large number, right? So it's going to look for all of these items inside of the database, just like that. And as you can see, there's the right ascension proper motion and the declination proper motion. There's also a magnitude. There's radio velocity. Here is the RA in the deck, right? So temperature, yeah, we're going to show all kinds of things. And it's going to do it at that location with that radius. And these, of course, are all in degrees, right? So let's submit this query. And we'll see how many stars we actually get. No results found. None. Wow. Oh, no. Sorry. Premature. All right. So it came up with 425 stars in a area of the sky the size of the full moon. So let's go back. I want that number to be, a few thousand, right? So let's go back here and let's quadruple the area, right? So now we're talking about a 30 arc minute radius, a 60 arc minute diameter. So we're quadrupling the area. Whoop! I didn't mean to submit that. I want to show it because I want to change this to like 10,000 or so. So this is about 4 times the size of the moon. Let's see what that shows. Oh, okay, so 1,817 stars. That's enough. Okay, so I'm gonna download this as a CSV file, a comma separated. I don't know what the V is, but each column will be separated by commas. So then I can come over here and I can download the results. Let's see, can I do that? Is it going to, okay, yeah, so it's going to save it just like that. Let's do ADL 001.csv, because of course we want to look at this file just so you can sort of see what's going on with that. Oh, I should have opened it right there. Wow. I can go another way here. Just go this way, and this way, and this way, and that. So let's look at this file first. Every single time I go into this, it has to re-index. So while it's re-indexing, I'm going to take a gulp of this wonderful hydrogen hydroxide. Cheers. Slowly but surely indexing. Slowly but surely. Should come up at the top. I think I'm ordering this by the last time it was touched. Yeah. So should we look at this with a spreadsheet? Yeah, let's do that. Let's look at it like a spreadsheet, because that'll make it a lot easier to see, to visualize for you folks out there. So here we go. So here's the ID, here's the right ascension, declination, the proper motion, right ascension and dec, also the magnitude. Some of these numbers aren't available, so they're either left blank or it says not available. Some of them are, some of them aren't, but yeah, there are 1,800 and however many here, right? And some of these have proper motions, right? you got to remember that H and I here are the proper motion columns. So not all of these stars have measured proper motions, but quite a few of them do. Right, quite a few of them do. Of course, all of them have positions. That's sort of the main point of this catalog, right? Is to get very very accurate and precise positions of all these stars in the sky. So let's start up GIMP, not GIMP, GNU plot, and we're gonna look at some. We're gonna make some plots. So the first thing I have to do is go to the same place that this file is in. So I do that by going over here and going 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 here. Okay, so then let's plot the RA and DEC first. And what I'll do is I will plot RA and DEC and magnitude. All right. So how I'm going to do that over here is I'm going to say ADL using now GNU plot starts with column 1, right? So the RA is in column 2 and the DEC is in column 4. 2:4. And then I'm going to have, I want to plot the magnitude by changing the size of my dot, right? So the bigger the dot, the brighter the star. So this is where GNU plot gets really, really, really cool because I can create these variables. So and I can have the variable actually be a mathematical function. So I'm going to say 22, which I think is sort of the limiting magnitude of Gaia, minus, and I'm going to say whatever column this is, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So column 10, and then I'm going to multiply that by some factor. What I want is to have a dot size, maybe between like 0 and 5. So I mean, through experience, I sort of know what this is. But as you can see, I take this one here, right? If I say, so if I take 22 and subtract 20 from it, that gets 2, and then I multiply it by 0.15, that works out to be, like less than 0.4. So a faint star like that is going to be a very, very, very small dot. Whoop. If I, let's see if we can find, yeah, see, so here's like a brighter one. Here's like a 13th magnitude, right? If I do 22 minus 13, that's 9 times 0.15. That's almost a point size of 1. So I think that'll work out just fine. With points, I want the point type to be a circle, so that's point type 7. And I want the color to be black, but I want the point size to be this variable, like that. So that should produce something. Whoop. Oh, yeah. There's one more thing that I have to do. I have to tell it that the column separator is a comma. By default, it'll think that it should look for spaces. So data file separator. I'm typing with one hand here. Comma. Okay, so let's do that. And there we go. Whoop. So that's not too bad. That's kind of that's probably a little too much here. So let's knock that down to maybe 0.1. There we go. So and it's only oval shaped, right? Because it's trying to fill the entire screen, right? Let me see if I can try to make this a little bit bigger. And maybe I'll try to make it a little more square also. I don't know if it's gonna let me do that or not. Try to replot it. Okay, so that's a little bit more round. Let me bring that in a little bit. We'll try to make this as realistic as we possibly can. Wow, man, this thing's driving me crazy. Okay, well that's pretty round. That's pretty round. And so the larger the star here, the brighter it is. See, so that's a pretty bright star. That's a really faint star. So yeah, this is just a random field of stars. And as you can see, the x-axis here is the right ascension in degrees. So in order to convert that to hours, you have to divide that by 15. So yeah, and declination is just that. So yeah, just sort of a random field of stars. How many were there here? 18. So 1,817 stars. That's what we're seeing there. And as I said, this field of view is like 4 full moons, right? So, you know, a full moon could fill about a quarter of this. So that's a pretty sizable piece of the sky, right? That's 1 degree from here to here, and we can actually confirm that, right? We're going from about negative 16.1 down to negative 17.1. So yeah, that's about a degree in the sky. So that's a pretty big chunk of sky. But I wanted a sizable number of stars, and we're obviously looking in a relatively um, uh, not very dense area of the sky. And you know, this of course is where you would stop if you were wanting to build like a finder chart, right? But I always like to look at these, you know, because I start seeing patterns. Right, here's a row of 3 similar stars, and here's a line of stars here, and a little arc of stars here and here. There's all kinds of patterns. I I usually see triangles and lines when I look at these kinds of things. So yeah, and that's exactly what I'm seeing here. There's always, you know, our brains, even if it's random, which this probably is to a certain extent. Our brains always want to see patterns, right? There's you know, this circle, right, with nothing there, and there's this with nothing there, and yeah, you know, I mean, our brains want to see patterns, and that's exactly what we're seeing here. So, but what I'm interested in is making a plot like that other one with the proper motion instead. So um, let's do that. So let's keep this magnitude thing the same way. So the size of the dot will be the brightness, right? But let's look at the proper motion, how these things are moving in the sky. So for that, I want to use this column and this column, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of 2 and 4, I want to do 8 and 9. Let's do 8 and 9 here. We'll leave everything else the same. We'll plot everything. And let's just see. This is just a random piece of the sky, and we're looking to see how these stars are moving in this piece of the sky. So let's take a look. Probably what we have to do is start over, which sort of sucks, but that's how it goes sometimes. So we'll get to the right place here first. It's always a process. With one thing in astronomy that you have to be is patient, because there's a lot of tedious tasks that must be performed. So let's set the separator there to commas, and let's look and see that shows. Ah, interesting. Kind of interesting. Let's unset the key. We don't have that interfering our view. Oh, come on. Okay, so let's replot that. And let's make the sizes a little smaller now, because we're looking at this in a different way, and we really want to see, well, let's look at the big one first. Let's look at the outliers first. The outliers are always kind of interesting. So, of course, so here's 0, 0, right about there. So those are stars that aren't really moving very much at all. But look at some of these outliers, right? This guy, this star here, is moving south at 150 arc seconds per year, right? That is chugging along, right? That thing is flying south, almost due south, right? Because here's 0 degrees per arc second in RA. So it's not moving very much in RA, but it's moving a huge amount in DEC. So this one is also moving a huge amount, but it's moving a little more west, right, than that one. So yeah, some interesting outliers here. See, everything here is sort of moving to the west. Yeah, interesting. So let's change the size of the dot so we can sort of start to look inside of that cluster a little bit, see if there's anything interesting in there. So I can change the range here a little bit. So let's go from negative 100 arc seconds per year to 100 arc seconds per year in RA and DEC. Negative 100 to 100. And whoop, typo. There we go. Let's make these a little smaller. Really start to dive into the middle here a little bit. See if there's any interesting population. So again, this is not position data. This is motion data. This is how these objects are moving in the sky. So it's just a different way of looking at things. right? Which, I don't really see anything too exciting here. Um, the only thing super exciting, super interesting, is all these guys out here that, you know, for the most part, right? Stars are going to appear to be moving not very much, not very much, but we do have. Um, I'm going to knock this down just a little bit. 0.75. Now let's look again at this one. It sort of seems to me that there's sort of a population of stars over here that are sort of moving in some kind of recognizable pattern way. I don't know. Let's go negative 50. Let's do a deep dive here and see what we can find. This is the kind of work that astronomers do. Now it's a little bit more organized and intelligent than what I'm showing here. But yeah, I'm trying to give you sort of a general idea of sort of the kinds of things that you can do with um, this kind of data, which is available to us all, right? Okay, so now we're looking at stars that are moving um, both in RA and DEC between uh, moving east and south at 50 arc seconds per year to moving uh, west and north at 50 arc seconds per year, right? So, for instance, this star here, right, this little guy right here, is moving, and actually I can read the coordinates here, right? So I can put my cursor on here, and it says that that thing is moving about 31 arc seconds per year to the west, right? To the east, I'm sorry. Positive RA is to the east. And it's moving at about 38 arc seconds per year to the north, right? So I hope that makes sense in order to allow you to understand this plot. As I said, this is not a position plot. This is a velocity plot. And as you can see, right, most of the stars are sort of, you know, centered around this area. It is kind of interesting, though, isn't it, that there seems to almost be a diagonal line here where all the stars are over here and there's no stars over here. So, what does that mean? Well, the stars over here are moving north and west, and the stars over here are moving south and east. So I'm not quite sure what that means. I would I would I would think that so there's sort of a preferential motion towards the south and the east. Hmm. Don't know what that means. Don't know exactly what that means at all. Kind of interesting, I suppose. This it's kind of a yeah, I mean, it looks like there's all kinds of interesting structures in here, right? So again, a lot of that is just our brain trying to find patterns in randomness. Um, Whether they're actually there or not, it's hard to tell. one of the things that we can do is let's just look at column 10, just proper motions. I'm just going to do it like this using, and this is not going to, it's not really going to show me what I want to show, and that is sort of a distribution. I would need to make like a histogram plot in order to do that. But let's just see what this shows anyway. So I'm just going to look at column 10. Um, um, points, point type 7, which is a dot again. Point size, let's just make it 0.5, and we'll make it, we'll make these red. Who cares? Okay. So, whoop, did I not get the right column? Oh, that's magnitude. These are magnitudes. Sorry. Let's look at the right ascension proper motion 8. Okay. So yeah, most of these are about 0, and but there is sort of a preferential. There's more stars that have a positive proper motion in right ascension than negative. So that's kind of interesting. And let's look at the declination. See, that looks more evenly distributed, right? There's sort of an equal number of negatives than there are positives, maybe a few more negatives. And I think that's what we're seeing in this plot, right? So yeah, kind of interesting, kind of interesting. But yeah, anyway, those are the kinds of things that you can do with Gaia data. I cannot believe that it's already 7 minutes after 3 UTC. That just blows my mind. So yeah, those are the kinds of things that you can do with Gaia data in order to sort of, begin to understand what it's telling us. So yeah, this guy's really moving fast east, 250 arc seconds per year. Yeah, that's absolutely amazing. That thing is just screaming east. So yeah, definitely somebody should take a look at that guy. Now, I mean, what I could do, right? What we can do is we can go back to Gaia. Let's look and see. Let's sort of see if what we're plotting here um, is actually what the database will produce. Now, I'm seeing 4 stars that have a right ascension proper motion greater than 150. Okay, so let's go back to this database here. And one of the other things that we can do is we can set some conditions. So let's add a condition. And I didn't mean to add 2. And let's look for proper motion RA. And let's say that it has to be greater than or equal to 150. 50. That. So now let's show our query. And as you can see, it's added this thing that PMRA has to be greater than 150. I'm going to set this to 10,000, but if I'm reading my plot right, we should only see the number of rows equals 4 here. Now let's see if I'm right or not. Yeah, smash the thumbs up if you so desire. There's only 4. Yay. Cool. So yeah, that works just as expected. So yeah, that obviously just picked out these guys here. Now, I mean, with a more sophisticated query, I could actually say, I want to look at the, well, yeah, I could plot this exactly the same way too. I could look at all all the proper motions between 0 and 50, right? Um, in RA, and I could do that either by making a query, right, to set those limits, or I can just do it here, 0 to 50, and there they are. So these are all the deck um, um, proper motions, and all the proper motions in right ascension between 0 and 50. Let's make these dots a little smaller so we can sort of see. So, you know, there are so many ways to visualize um, data, right? It's absolutely insane. So, um, but yeah, these are how plots are created that you see in these papers. Um, and yeah, if we're interested in seeing what you know which stars are moving between like 30 and 50 arc seconds per year in right ascension and 30 and 50 arc seconds per year in declination. There's only one. Wow, there's only one. So let's change that. Let's go from like 10 to 30 in deck. There's a few more there. Let's go -10 to -30. See a few more there. Oh, it vanished. New plot is awesome. There's a few more. See, where are they all? I don't know. Here's all of them. Oh, let's just do this. Let's go -5 to 5 and -5 to 5. That'll be centered then around 0. Oh, there we go. So these guys right in here are barely moving at all, right? And as you move out from the center, that's signifying that these guys are moving faster in some kind of direction. So, each of these points sort of represents a vector, right? There's so many ways to interpret this, but yeah, that's kind of a cool looking plot there. Yeah. So one of the things that we can do, let's do this. Okay. So I'm gonna I'm gonna go back to the database here, and this will be the last thing because I mean I could spend all day doing this. Let's pick out these stars, right, that have a proper motion from -5 to +5 in both axes, and let's plot their positions in the sky. Okay, so let's go back to this, and let's say that PMRA is going to be greater than -5, and so now we're going to add another condition. PMRA is going to be less than +5. Okay, and we're going to do the same thing for the deck. So PM deck greater than -5, and PM deck less than or equal to 5. Okay, let's look at that query. So there they are. Okay, same size, same coordinates, same everything. So let's. I'm just going to change this. I know that there aren't going to be 10,000 of them, but I'm going to set it to 10,000. There's going to be, a couple hundred, I guess. 333. Haha. I like it. Okay, so let's do that, and we'll save this as ADL002.CSV. Okay, so now what we can do is we can come over here, and well, let's take a look at it first. Oh, where are you? Date. There it is. Okay, so here's that one, and so these are all the stars that have a proper motion in RIN deck between -5 and +5. So now I'm going to plot their positions in the sky. All right, so that's column 2 and column 4. And we'll do the same thing. Whoop, looking at the wrong thing here. So we'll do the same thing as we did here with the magnitudes. We're going to do column 2 and column 4. And it's ADL2. And we're just going to let it set its own limits. So there they are. So those are the stars as they are in the sky, right? So we can actually let's do both. Let's look at both. Set multi-plot, layout, 1, 2, at, and then let's plot this one and ARG and this one. Stretch this out a little bit. Well, can we do that? Stretch it out a little bit. Probably have to unset multi-plot. Okay, yeah, well, I'll have to replot that in order to make them square, but I don't have to retype anything. So here's the positions, and here's the proper motions. So this is the same set of stars, right? Same set of stars, and I mean, we can pick out a few of these, right? I mean, the bigger ones here are obviously these guys, right? But yeah, there's absolutely no relationship at all between position and velocity, right? Maybe if some of these, were like binary stars or something, sure, yeah. But yeah, kind of cool. So here are the positions of the stars, and here are their um, um, motions in the sky. And yeah, kind of interesting. Anyway, yeah, we could spend hours and hours and hours doing this, but I am way over time, and I definitely respect everybody's time. I know that don't want to spend hours and hours and hours, not necessarily doing this. This is definitely nerding nerding out on Gaia 2 data. Maybe that's what I'll call this one in the title today. So, all right, I'm going to get out of here for now. Yeah, oh yeah, yeah. They are calling. I've got to get back up. Can only be here for a short amount of time. As I said, definitely respect your time. Glad for coming in. So until tomorrow, I hope you have a great evening, a great day. Smash the thumbs up if you so desire. Smash the thumbs down, which whatever you think. I like to have a reaction, whatever it is. Make some comments. Nice to see everybody in the chat. Um, yeah, I'm gonna have to do something about Mr. Calculator here. I'm not going to be a good scientist if I don't have this. I'm going to have to pull out my slide rule, which I don't mind doing. Don't mind doing it all. All right. Well, as I said, yeah, they are calling, so I'm going to get out of here. Take care, everybody. Hope you enjoyed that as much as I did. It's always really, really fun to really just nerd out on astronomical data. So, all right, I will see you all tomorrow, same time, same place, 2 hours UTC. Yeah, of course I know what a slide rule is. I will tell you tomorrow, okay? Remind me, because I'm not going to remember this at all. I will tell you my slide rule story. I have a slide rule story. All right. So take care, everybody. I will see you tomorrow, 2 hours UTC, a little less than 23 hours from now. So I'll see you on the spin. Take care, everybody. Bye.